Hello students, I hope you are good, well and fine, and today we will be diving deeper into the topic polynomials. So let's see what we will see next. Now we will dive deeper into roots. So first of all we see what roots of polynomial means and then do related exercise so that this concept of yours will get very clearly. Okay, let's see what do we mean by roots or zeros of a polynomial. So a real number alpha, so this alpha is any real number, is a root or zero of polynomial fx. We have a polynomial fx which is an xn plus an minus 1 x power n minus 1 till a naught. Okay, if f of alpha, this alpha we took this alpha, if putting this alpha in place of x, then we will get f of alpha, and then if this f of alpha is equals to 0, then we say this alpha is a root or zero of a polynomial. Okay, I hope this is clear. So in other words, it means that putting alpha in place of x, we will get an alpha n minus 1. Here it will be alpha n minus 1, an minus 2, alpha n minus 2 till a1 alpha plus a naught. And if this all goes to 0, this means that my alpha is a zero of a polynomial. For example, take x is equals to 3 and my polynomial is this fx cube minus 6x square plus 11x minus 6. If you see that my polynomial is cubic, yes, because the degree is 3. Degree is 3. The degree, what do we mean by degree of a polynomial? Degree of a polynomial means the highest power of x in the given polynomial. So here is this. Okay, now what? Now if you see that by putting x is equals to 3, what I will get f of 3, which is 3 cube minus 6 times 3 square plus x 11 times 3 and minus 6. So here it will be minus 6. Okay, now just solve it or simplify it. So 3 cube means 27, 6 times 3 square, which is 6 times 9, and 6 times 9 is 54, and plus 33 minus 6. So if you add these two, you will get 0, and what you will get? You will get 60, and adding this you will get minus of 60, and finally you will get 0. So by this example, or by putting x is equals to 3, you saw that x is equals to 0 for x is equals to 3. So this means x is equals to 3, or 3 is my zero of the polynomial x cube minus 6x square plus 11x minus 6. I hope this is clear. If you consider x is equals to minus 2, so if you consider x is equals to minus 2, then let's see what will happen. By putting x is equals to minus 2, you will get minus 2 whole cube. This will be not here, the okay, so minus 2 whole cube minus 6 times minus 2 whole square plus 11 times minus 2 minus 6. Okay, now solve it. So this will be minus 8. This what it will be? 2 square is minus 2 square is plus 4, and 6 times 4 is 24, and this will be minus 22 and minus 6. So all the terms are negative, so the answer will be for this is 22, 24 and 6, 8, and we just add them to get the answer, final answer, and the final answer will be my negative. So let's see. So this and this will be 2 and this 60. So yes, the minus 60. If you see, the f of minus 2 is equals to minus 60. I hope this is clear. So what this means, that minus 60 is not equal to 0. This means minus 2 is not a root of the given polynomial. Okay, so we saw what do we mean by root or 0 of a polynomial. Okay, so whenever someone says that alpha is a root or 0 for a given polynomial, then this means that putting alpha in terms of x, you will get f of alpha equal to 0. I hope this clears the concept. Let's move next. Now, value of a polynomial. Okay, let's see. A value of a polynomial means that value of a polynomial fx at any point, say alpha x is equals to alpha. In previous slide, we saw x is equals to alpha, where alpha is a root. Okay, alpha is a root for the given polynomial. Okay, I hope this is clear. Now we are talking about the value of a polynomial fx and value at x is equals to alpha point. Okay, so how we are going to do that? It is quite simple. Just replace x by alpha and you will get your respective value. For example, if my polynomial is this, fx is equals to 2x cube minus 13x square plus 17x plus 12. So now the value of the polynomial at 1. So we are talking about the value of the polynomial at 1. So just replace all the x variable by the constant value 1. So fx will be f of 1, 2x cube will be 2 1 cube minus 13x square becomes minus 13 1 square, and so on. 17 times 1 and 12. Just solve it. So 1 cube is 1, so it is just 2. 1 square is 1, so it is just 13. 17, 12. Now by adding you will get so this and this will give me 30. Okay, and 30 and this, sorry, no, if you see, this is of a minus sign, so this and this will give me minus 1, and to this will give me 16, and 16 plus 2 will give me 18. I hope this you can easily do. Okay, so let's move to next. Now let's see more example to polish your concept on zeros of polynomials or the value of the polynomial at any given point. So here we have to find out, or we have to show that x is equals to 2 is our root of the polynomial this. So if this is our root, this means if I put 2 instead of x, I will get what I will get. I will get equals to whole expression equals to 0. If this is true, if this is true, then I will say that 2 is my root. Okay, 2 is my root or 0 of the given polynomial. Let's see that is it really going to happen that this expression is equals to 0 or not. Let's see. So 2 cube is just 8, 2 square is just 4, and this will be 14 and minus 16, and this will give me minus of 20, and 8 times 2 is 16, 16 plus 4 is just 20, so 20 minus 20 will give me 0. So indeed x is equals to 2 is my root of the given polynomial 2x cube plus x square minus 7x minus 6. I hope this clears it. Okay, let's move to next. Okay, here's the solution. So let's see the solution again. So I'm assuming my this expression equal to this polynomial in term of x, px is equals to this, and now I am going to find out the value uh, of the polynomial at the point x is equals to 2. So just replacing every x by 2, I will get this. So here it will be minus sign. Okay, so 16 plus 4 is 20, and minus 14 minus 6 is minus 20. So this is my 20. This will come. So I hope you understood it. Let's move to next. Now, example, if x is equals to 4 by 3 is a root. Okay. This means we are given that x is equals to 4 by 3 is my root of the polynomial this. Okay, my polynomial is already given. Then find the value of k. So this means that f of 4 by 3 will be 0. Yes, because it is a root of the given polynomial, and my polynomial is this f of x. Now what? Just put or replace x by 4 by 3. So 6 times 4 by 3 whole cube minus 11 times 4 by 3 whole square plus 6 times 4 by 3 minus 20 will equals to be 0, because this is a root. So for root, this is my condition. Okay, let's solve it, and you will get your value of k. Let's see. Now here we are. Now let's move and see this other steps. So just performing these just manipulations, you will get your k value like this. I hope you can do it and just verify yourself also. So let me just make it simplified. Okay, so here this is just I am taking common terms out. So my common terms is 4. So 4 times 3, so 4 5 and say 57. So this is the value for k. I hope you can easily solve it and you will eventually get your answer correct. Okay, so let's move to next and see other questions. Now here, if x is equals to 2 and x is equals to 0 are two roots. So I have given two roots, x is equals to 2, one is this, and x is equals to 0, second is this. Now what? Now two roots of the polynomial fx. So my polynomial is also given 2x cube minus 5x square plus ax plus b. So I have to find out the value of a and v. So it is quite simple. Just solve it like this. First of all, f of 2 is equals to 0, and also f of 0 equal to 0, because both 2 and 0 are my roots. So let's solve it and find the a and b value one by one. So let's see. So f of 0, what it is? So 2 times 0 cube minus 5 times 0 square plus a times 0 plus b equal to 0, and we know that any number multiply with 0 will give me 0 minus 0 plus b equal to 0. From this I can say that b is equals to 0. So now value for b is 0. Let's do it for this. For this, f of 2 will be 2 times 2 cube minus 5 2 square plus a times 2 plus b is equals to 0. We know the value for v, which is this, v is equals to 0. So I just replace the value for v. Now this will give me 2 cube is 8 times 2 is 16 minus 2 square is 4 times 5 is 20 plus 2 times a is equals to 0. Now solving this will give me 4 plus 2a. The minus of 4 plus 2a is equals to 0. From this I can say that a value is just 2. So a value is 2 and b value is 0. I hope this is clear to you. Okay, so let's move further, and yes, indeed our value for a and b are as follows. Okay, so let's move next. So now we will see next concept of the value next concept of remainder theorem and their related exercise. Okay, so see here, remainder theorem. If you recall the long division method, in long division method, what you did. So let's see by an example. So I have a divisor, a dividend, and other terms also. Let's see. So I have 3, I have 22. Okay, so divisor, dividend. Okay, and here the quotient. Okay, now let's solve it further. So we know that 7 times is 21, and here we will get just 1. So, and this we called as remainder. So from this, if you see that 22 is equals to 7 times 3 times 7 plus 1. Yes, so in general, if you recall that a dividend is equals to a divisor times quotient plus the remainder. I hope this is clear to you. Okay, so this thing we also follow in polynomials, and how we use this in polynomial, let's see. So if my px is any polynomial of degree greater than or equal to 1 and a be any real number, so a is my any real number, and if px is divided by x minus a, then the remainder is equals to p of a. I hope this is clear to you. Let's see more deeply. So this you all know. So dividend is equals to divisor times quotient plus remainder. Okay, so I can write my polynomial px is equals to, if px is divided by, that means this is my divisor, so x minus a is my divisor, then there must be some quotient. I am saying quotient is equals to qx, quotient is my qx. Okay, so now there will be also some remainder left. So remainder, this rx is my remainder, so just adding rx will give me this px. As you saw in this example, this is my dividend, which is equals to the divisor times some quotient plus remainder. Okay, so taking that analogy, we say that px is my any polynomial, and if this is my divisor, then divisor times some quotient plus some remainder will give me my original polynomial. Okay, so in this case, please keep some points in mind, that this remainder degree, so all are polynomials. We know this polynomial is linear. Okay, this might be some of degree, we don't know yet. Okay, this also we some degree. Okay, but here always keep in mind that this degree of Rx polynomial is always less than the degree of divisor, I hope this is all clear to you. Okay, so this is written over here. So degree of Rx is less than degree of x minus a. So here it will be x minus a. Why? Because x minus a is my divisor. Okay, x minus a is my divisor. So this means if you see that my degree of this remainder polynomial will be strictly less than the degree of divisor, and my divisor is of linear. So in linear the degree is equals to 1. So this means degree of the polynomial remainder polynomial is strictly less than 1, and we know degree must be either 0 or positive. We cannot take negative value as my degree. So the possible value for this to be either Rx is 0 or Rx is just constant. If it is a constant, that means the degree is 0. If is 0, that means our polynomial is 0 polynomial. I hope this clears. Okay, I hope you remember what do we mean by 0 degree of the polynomial and 0 polynomial. So let me recall you the concept. So 0 polynomial means any polynomial which is equals to 0. Okay, for any x we want. Okay, so for if you put any value for x, you will only get your answer as 0. I hope this is clear. Now 0 degree polynomial, and also know that in this note degree in 0 polynomial degree can not be determined. Okay, but in 0 degree polynomial are those polynomial where my px is equals to some constant but not 0. In this case degree is equals to 0. I hope you recall the both of the concepts. Let's move to this remainder theorem. So I hope you understood it very well. Let's move next here. So I am taking Rx is equals to R. So don't forget that this is my polynomial in X. Okay, so this means Px is equals to the divisor times the quotient, which is Qx plus R. R is my polynomial in term of X. Okay, so now put x is equals to a. So if x is equals to a, then this term, this divisor term will be a minus a, and a minus a means 0. So 0 times quotient will be just 0. So this means p of a is equals to r, and r is my remainder. So this means we know if x minus a is my divisor, then p of a or f of a is equal to remainder. So that's why we said that if px is any polynomial of degree less than or greater than or equal to 1, and a be any real number such that x minus a is a divisor of px, then p of this a will equals to remainder. I hope this is very clear to you. Let's see a remark. If polynomial px is divided by x plus a, then what if polynomial is divided by this divisor? We are given a different divisor. So this divisor is different, divisor 1, say divisor 2, divisor 3, divisor 4. Then what we will say, then if you see in the case if divisor is equals to x minus a, then we know p of a is equals to remainder. Yes, remainder. So this means that this x minus a, if you put it equals to 0, then x is equals to a. This value is my remainder. Sorry, this value, at this value the polynomial give me the value for remainder. So applying same logic here, in x plus a equals to 0, x is equals to minus a, so p of minus a will give me remainder for if only the x plus a is my divisor. For in this case, put this ax minus b is equals to 0 and solve for ax, you will get b by a. So it is given b by a is my remainder. Okay, I hope and you are getting what we are doing. Okay, so I hope this is very clear to you. So let's move next. Let's see by an example that we have to find out the remainder, and my polynomial is given like this, and the divisor is like this. So in order to find the remainder, just put the divisor equals to 0, which is gx, which is 1 minus 2x, which is equals to 0. Now solve for x, you will get x is equals to 1 by 2, and now put that value, or just find out the value of the polynomial at 1 by 2, that means f of 1 by 2. So 1 by 2 whole cube minus 6 1 by 2 whole square plus 2 1 by 2 minus 4. And after solving, whatever the number you got, this will be equals to the remainder. Okay, I hope this is clear to you. Let's see. So you will be getting like minus of 35. So putting this, you will get x is equals to 1 by 2. So half cube is 1 by 8 minus 1 by half, minus 6 times 1 by half square is 1 by 4, and 2 got cancelled. So 6 times 1 by 4 will be 3 times 2. So yes, 3 times 2. Now just 2 get cancelled, so 1 and minus 4 is already there. So this will be, if you solve it, you will get what you will get. Let's see. So my LCM is just 8. 1 minus 12 minus 24, and after minus 11 minus 24 by 8, you will get minus of 35 by 8. So yes, indeed, my remainder will be in this case minus 35 by 8. I hope you understood it very well. Let's move to next example. The polynomials you are given with are ax cube plus 3x square minus 13, 2x cube minus 5x plus a are divided by x plus a. Okay, so we are given with two polynomials, and both of the polynomials are divided by the same divisor. So then what the question asking for, the question says that if the remainder in each case is the same, so the remainder is the same. Okay, so find out the value of x. So we have to find out the value of x according to the question. If you put x is as because the divisor is this, x plus 2 is my divisor, so putting it equals to 0 will give me the point where I can get my remainder. So it is minus 2. So now putting minus x is equals to minus 2 over here, and x equal to minus 2 over here, and equating them both equals to each other, I will get my value for a, because the remainder in each case is the same. That's why I am putting both the expression equal to each other after x is equals to minus 2. Okay, so let's see. So we know we have two polynomials, a px and qx, and from where I can get the remainder is by putting x is equals to minus 2. Now p of minus 2 is my remainder for this polynomial, and q of minus 2 is my remainder for this polynomial, and we know from the question that both of the remainder are equal or the same. So that's why I use this equal sign over here. Now just solve it by just replace every x by minus 2. So a times minus 2 cube plus here it will be cube, so plus 3 times x or the minus 2 square minus 13 and is equals to 2 times minus 2 whole cube minus 5 times minus 2 plus a. Now solve it just quickly. So it will be plus 10, it will be minus 16, this remains untouched, and this is just a 12, and this is minus 8a. Okay, I hope this is clear. So now solve taking this let me just take this right hand a to the left hand, so this will all get to minus a minus 9a, and taking these all values to left side and solving it further, this will give me plus 10 minus 12 plus 13, which is plus 1 plus 1, and this gives me just minus 6 plus 1. Okay, so minus 6 plus 1 is minus 5, so minus 5. So this all right hand side is equals to, so minus 9a is equals to minus 5. This means a is equals to 5 by 9. I hope this is clear to you. Let's see next examples to understand more. Okay, so now here we will see the factor theorem. So this factor theorem says that if px be a polynomial of degree greater than or equal to 1 and a is my any real number such that pa is equals to 0. Okay, pa is 0. So if you recall, what do we mean by 0 of the polynomial? Any number which on putting in place of x, if gives the polynomial expression is equals to 0, then that value will be called as the 0 of that polynomial. So here if a gives us, a is my such value that p of a is equals to 0, that means a is my 0 of the polynomial, a is my 0 of the polynomial px. Okay, I hope this is clear. So, and there's another way to say that is that x minus a is a factor of a px, because if you see from the say the remainder theorem, we know the px is equals to, say if this is my divisor times some quotient plus remainder, and we know p of a is 0, so taking x is equals to a, p of a is equals to, say this is a minus a q x plus r of a, then p of a is equals to, this becomes 0 already because a minus a is 0, so this is equals to r of a, and now we know that p a is 0, so this means r of a is 0, that means the remainder is equals to 0. So my remainder at of the polynomial is 0. So this means this means I can rewrite my polynomial like this. So from here I can say that this polynomial can be rewritten as product of two polynomials. One is, and both the polynomials I will call them as a factor of the polynomial. I hope this is clear. So if p of a is equals to 0, then then the x minus a, we call it as a factor of px. So factor means that this polynomial will completely divide, or by if this divides the our original px, then the remainder will be equals to 0. Okay, I hope this is clear. Let's move next. So let's see an examples to understand better. So show that x plus 1 and 2x minus 3 are factors of this polynomial. If both of the polynomial are factors, then that means putting x is equals to minus 1, I will get this equals to 0, and putting x is equals to 3 by 2, I will get same value as equals to 0. So let's see I am getting or not. So taking p of minus 1, that is taking this x plus 1 is equals to 0, imply x is equals to minus 1. So p of minus 1 is p of minus 1 2 minus 1 cube minus 9 minus 1 whole square plus minus of 1 plus 12. So this will become minus 2, this will become minus 9, this will become minus 1, this is all remains untouched. So adding this in negative, I will get minus 12 plus 12 which is equals to 0. In similar manner, if you try the find out the value for p of 3 by 2, you will get equals to 0. So this means by the previous factor theorem, I can easily say that x plus 1 and 2x minus 3 are the factors of this cubic polynomial. I hope you understood it, and we have seen an example of the factor theorem, and you will see how we are going to apply in other problems also. Okay, so that's it for today. So thank you for now.